Okay, so this is the review for the final. It's the very last day of the review. I have covered everything once, but I'm going to briefly cover a few things again, things that were like on this packet. And I shouldn't say I've covered everything. I've briefly covered each type of topic, but each topic could be 3-4 days of review by itself. So no, I haven't covered everything. But I briefly, before this video, covered a lot of each topic. So now, I've been asked to do another problem that's kind of like this. You graph this, you shade underneath them both, and you end up with a feasible region kind of like this. Do you want to go over how to graph them? How you actually get those things graphed? Because if they give you the equations like y equals negative 2x plus 30, you can just type it in your calculator. You'll have a calculator for that part. Okay? So the calculator can graph that. And then let's say this other one, I'll make it a blue line here. This other one, let's say that it's y equals negative x plus 25. If I have these two equations, how do I tell where they cross with a calculator? Just graph both of them, and how do you see where they cross, though? So I can calculate the intersect. Everybody, I may not have you do this one, but you'll need your calculators in a minute. So everybody, would you grab your graphing calculator? I'm going to ask you to type in something in a second here. I'll pause while you pull those out. Okay. So if you were to graph these two equations and see where they cross, you'd hit second, calculate, and then what's that word you're looking for? Intersect. Good. What if you want the spot where y equals 0? Then what you do is you take this equation and you don't use a calculator. You could just say y equals 0. Stick in a 0 right there and solve it. That's a baby equation right there. You just subtract 30 and divide by negative 2 and you'd have it. Option B, you can type in y equals 0 on your calculator. You got a y equals screen, right? And then you could see where these two lines intersect. Second, calculate intersect. But, and it's a big but, this is the y-axis and it's x equals 0. And do you get your calculator on? It doesn't have an x equals option. It has only y equals things. So would you please type in this equation right here, and I'll show you how you can make it have x equal. So just type in that equation on the y equals screen. Negative 2x plus 30. Just to clarify, you cannot use the minus key for this. It has to be the little negative key that's at the very bottom row of your calculator. Okay, now hit graph. Now, if you want to see what that answer is, if x were equal to 0, if x equals 0, then can you see in this simple, super simple little equation, that actually makes this cancel out, and its answer is just y equals 30? But on the calculator, there's a little special function for this. Go to second, calculate. It's right above trace. Second, calculate a value. As soon as you hit the button called value, second, calculate value, do you see what pops up? Second, calculate value. What pops up? X equals. So if you want to say x equals 0, that's how you do it. Or if you wanted to say x equals 1, or x equals 2, or x equals 7, that's where you could do it. Yes? You can also just go to trace screen. You can type in the value. That is cool. All right, I'm going to pause for a second and get my calculator up. All right, so I've got my calculator up, and the suggestion was if I go in, I'm in a weird mode. This is a mode you're going to learn next year where it's got an x equals and a y equals on the screen. Never seen that before? Okay, those are called parametric equations. But if I go into my mode and I change it out of parametric, yours is probably abbreviated para. I'm going to go to function mode, which is the normal mode, and then go back and hit graph again, y equals, and I should probably go to zoom 6, which will clear out this thing's zoom 6, the standard zoom. back to y equals screen. I'm going to pause while I get this. Okay, so here we go. I've got my equation ready to go. And once I graph it, no big surprise, I get my equation on the screen, I hope. Unless I got to zoom it. Oh, I do. That's right. I went out so far. I got to go. I'm going to do a special kind of zoom called the zoom fit. I think that you guys are going to use that a fair amount next year. That's zoom 0. Okay, so now I've got my graph on my screen. What somebody was just telling in class was that if you pull up the trace key, then, and you want to go to x equals like 5, all you got to do is hit a 5, and look at that. It knows that you want x equal to 5. Okay, so the trace key is right below the calc button. It's where I've always been saying go to second calc. It's that button, trace. And then if I hit any number, it just will jump right to that spot. So let's say that you're on this line and you want to know where time is 7. Well, that means x is 7. So you'd go to trace, and I can just hit 7, and it'll know that x equals. Okay, the other way I showed you was to go to second calculate, where a lot of these things are. And which one was it? Value. Second calculate value, and that'll bring up the x equals. And then you can say 7, and it'll jump to it. But the trace is kind of cool. One thing I wish you could do, and maybe you can, and I just don't know how, is if you get the other equation on the screen, if you could go to trace and then just have it jump to intersection points, that'd be pretty neat. But I think you have to do second calculate intersect to find, let's say there was a line going through here, to see where the two cross. You can get close with your trace thing, but you can't get the exact answer. I wish if you were really close to something, you could just hit like a button and have it jump to whatever's logical point that's close to it. All right, the thing that's kind of funny about this stuff is that you guys are learning with this calculator, and it'll be so different like 20 years from now. Like, for instance, 20 years ago, there was just really basic calculators. They didn't have these graphing ones. And you go 20 years before that, and they didn't even have calculators, like literally. Like when I went to high school, which would be about 27 years ago, you just had the first calculators, and they certainly couldn't graph. So you go back to like 30 years ago, they didn't even have calculators. So, well, they didn't have handheld, like personal walking around calculators. Maybe 30 years, but you go back 35. Go back far enough, and in the span of time, this is a ridiculously short amount of time. In a short amount of time, we've gone from having no calculators to having calculators to having graphing calculators. And then your kids will probably have, like, I don't know, holographic graphing calculators. Yeah, like it'll pop up on the screen, and it'll be like, see where they cross. And somebody will still be sitting in the class not doing their homework or falling asleep. All right. Okay, so anyway. Sure, blame that. All right, what? So, next topic. Somebody asked me about that one. That's why I was doing that. What else do you want to know about this packet? Things that gave you trouble. Yes, ma'am. All right, we'll practice the one like that. Would you read it to me? I won't do the exact problem, but. And read me the equation options. Oh, you know what? I can see it here. All right, I gotcha. So, thank you. If you had something like this. Oopie. Let's go with that's a simpler one right there. Okay. This kind of equation is important, and it's got an x and the exponent. That's called what? Exponential. Good. So, do you generally know what they look like? Sketch me an exponential. Do this on paper. It'll get you moving, and you're more likely to stay with me. I know it's a little warm in here, and it's a Friday, almost, because it's the last day of school, right before normal. Yeah, I know. For you guys, it's not quite the same feeling as for the teacher, because when I get to this point, all I have to do is give you the final and then grade them. So it's kind of like a Friday for me. All right. So exponential graphs. I hope you know exponential kind of rises really steep like that. That's a lot of people have said that about technology and how things are changing. just think about this. In our societies, if we went for like 1,000 years and the biggest change was they like started making tools out of a different thing. You know what I mean? Like they went from copper to bronze or bronze to copper. Anyway, they would, I know there'd be more advances than that, but can you imagine how many changes there are lately in the last like 50 years even? Like compare that to like, changes over 1,000 years versus nowadays, you wait 10 years and if you could fall asleep and wake up 10 years from now, there'd be pretty amazing changes. Whereas back a long time ago, the changes were so much slower. Definitely the change based on technology is definitely like this. I mean, if you put me to sleep and make me up in 50 years, I can imagine almost anything being possible by then. Okay, so that's exponential growth. How about if I change this to a 1/2? Now what is it? Exponential decay. And so that's, everybody to make a sketch of what you think that looks like. Exponential decay. Did you have it generally going down like that? That's what exponential decay looks like. Okay, now how about this 5 out in front? That's the starting value. Okay, if you put in x equals 0, you get that's like time is 0, like it just started the problem. Then do you get how this part turns into 1? So really that makes this the starting value. So that means this right there would be at 5. And it's going down from there. Okay, so what if I said, here's your general equation, that the moose population in Minnesota has been shrinking. It's been decaying, okay? And there were 4,000 moose, and there's down to like 2,000 moose. And I just heard the other day that there's some kind of a bill or somebody's moving to try to make the Minnesota version of moose on the endangered species list. And if they do that, that'll provide the moose with some more protections. Obviously, you can't hunt endangered species, for instance, and it might give them some extra, like, hopefully ways to bring the moose back. Now, the people who actually manage the moose say that they're afraid of that because then there's certain things they can't do to help the moose population anymore because they're like, I don't know, it's complicated. But right now, anyway, I can tell you this, Minnesota's moose population's in trouble. So let's say that we had 4,000, now we got 2,000, and it happened over the course of 10 years. Those can all be put in that equation. Try doing it. There was 4,000. Now, after a bunch of time, 10 years to be specific, there's 2,000. You can then figure out the rate from that. So everybody just start by plugging the numbers in. And then if you want to actually figure out the rate, you should be able to graph both sides and see where they cross. Okay. First, where does the current, the starting number for the number of moose, where should that go? Y, A, R, or X? A is the start value. That's the starting value of the moose. So that goes right here, and that is 1,000, what did I say? 4,000. Thank you. And now value. That's the end value. And that's kind of weird because it's going back in time. The ending value is 2,000. Over here at rate, do we know the rate? No, we don't. You can't put a number in there and just assume you know what rate that was. I know it's half as much, but that doesn't mean it's half here because it happened over how long? So the 10 goes here, and you have to be able to solve that. Now, I have two suggestions. Either A, you get the clump alone. This is the clump. And you get the clump alone by dividing by 4,000, and that's where you'd get your half. Because once you divide by 4,000 on both sides, then you'd have to put it to the 1/10 power. Option B, you graph both sides and see where they cross. All right. So that's pretty much a review of that topic. Is that enough for you? Okay, so if you want some specific points, like let's say this is a graph that's got a y and an x in it. So let's say that this is a y, and let's say that this is an x. Okay, now I've got my little equation, and it doesn't matter whether it's that equation or this equation, it'll be the same process. Okay, the first thing you do is you choose wisely. If you want points on an xy chart, you choose wisely for x and y. So what's a good thing to put in for x that's easy to work with? 0 is good. Okay, or 1 is obviously easy to work with too, but let's start with 0. If I put a 0 in here, what's 1 plus 0? 1. What's 1 to the 10th? 1. What's 1 times 4,000? So what's the point I just made? 0 went in and I got 4,000 out. That's what you're going to have to do. Pick a number, stick it in. So I want you to read me one of the equations that's actually on that problem, and I'll show you on your exact problem. All right, and now again, it's about choosing wisely. Don't just willy-nilly pick, I'm going to stick in 3. That's not going to work nice. What would work nice? I'll give you a hint. This number almost always works nice. 0. If I put in 0 for x, anything to the 0 power, not everything, that thing is 1. Then I add 6, makes 7. So I put in 0, I get 7. Now if I was looking for which graph this is, I'd look for a graph that has 0, 7 on it. See what I mean? All right. Is there another equation like that you want to look at, or should we just get another point on this? You got it now? Okay. Generally, you just want to pick numbers and stick them in that work nice. Another number that would work nice is 1. If I stuck in a 1, for instance, 0.5 to the 1 is 0.5, plus 6 is 6.5. And then I can get a bunch of points like that. I'll be able to tell which graph is which. All right. Another topic off the review sheet. Yes, you're next. Yes, which problem number is it so they can look it up? Everybody look at 39 briefly and see which one she's talking about. Thank you. All right, go ahead. Read it to me real quick. Want red and then what? Club. All right. I like to do this by just multiplying two fractions together. Okay. What's the probability of getting red? Well, if there's 52 cards out there, just to make it simple, how many do you want out of the 52 that are possible? There's 26 red ones. There you go. Times it by another fraction. This is just one of many strategies. You could have tried to do a CC over a C, or you could have tried to C with two parentheses after it, or you could have drawn a tree for it. It's a lot of strategies. This club, there's how many clubs are there that you want to be able to pick from? 13 clubs. Notice when I got a red card, I know I didn't get a club because clubs aren't red. Okay? So out of this one's tricky, it's not 52 anymore. Why not? You already drew a card out and you did not replace it. If you multiply that out, you'll find that it's the right answer. All right. So that was a probability one. Any have follow-up questions on this? Okay. What else do you want to know how to do? Yes. I would not have done a CCOversee problem because this one's got a sequence. I want this first, then I want that. Do you get how that changes it from I'm going to deal you 3 cards and you're going to pick them up all at the same time and the order doesn't matter? So if the order doesn't matter, you want to do CCOversee. Those are great. But the order matters on this. And therefore, since you have to have a red card and then a club, okay, can't explain that. Maybe you, I don't know how you could say that you could always have that. I can't explain why that worked. I can just say that I wouldn't have expected it to work because the order matters. But maybe because of the uniqueness of this problem that there's only one chosen, maybe that's what makes it work. I don't know. Okay, what else you got? Yes, sir. Sure. So here's a typical CCOversee. First of all, they're groups of things that are subdivided into smaller groups. Like, for instance, a big deck of cards. You guys are like a big deck of cards, okay, except you're not flat and two-dimensional, okay? But there could be like, you know, some of you could be like the queens of, okay, you're apparently the king of what? Hearts. All right, good. Ace of spades right there. And what? All right, you go, which diamond are you going to be? Yeah. Who are we going to vote as the Joker? All right, so anyway, if we're dressed very nicely today, so I'm going to subdivide you simpler. I'm going to make it just boys and girls. Okay, so I'm going to, you know what, just to save time, I don't want to have to count everybody. Let's say that out of, there is a total of about 30 of you. Let's say it's 16 boys and 14 girls, and that adds up to a total of 30, right? What's the probability that, and I'll show you how after, see how many people can do this without me. What's the probability that if I pick 2 of you, that I get 1 boy and 1 girl? It's a CCOversee question. Always start with the bottom, which is the totals. I'm going to pick 2 out of the 30 of you. I'm going to pick 2 out of 30. What's the probability that I'm going to get 1 boy, 1 girl? Those numbers are up here. There's 16 boys and there's 14 girls, making a total of 30 total kids. What's the probability that I'd get 1 boy and 1 girl? All right. So first off, did you get that the totals go down here? What's the biggest thing that it's all out of? 30. And how many was I going to pick out of the 30? 2. Those are the bigger numbers. Now these are the smaller numbers. How many in the subgroup here for boys? How many boys? And I'm choosing to get how many? And then this is 14, 1, and there you go. And if you, this and this add up to this, that's a good sign. And it's a really good sign if that and that also add up to that. And there you go. That's CCOversee kind of question. Any other topics that you want to talk about? I'm happy to answer a few more questions. Yes, ma'am. All right, let's do an optimization equation. Let's say that the 2 things that I am selling, like let's use Apple because they sell different kinds of products. If I was going to go with another phone manufacturer, they usually only sell phones. Apple sells Apple TVs, APP TVs, and this is going to be iPhones. Do you get that Apple wants to sell both of them, but might make more money on one versus the other? I mean, companies, even though they might be able to make more money selling these, they also want to sell those. Like at a restaurant, you can't, I make lots of money on pop, so I'm only going to sell pop. That's the stupidest idea ever, okay? You want to have a lot of options for people to come in, and some will order pop, some will order, you know, fries, some will order things that you don't make much money on, but that's okay, because as you know, you can't just have one thing. So let's say that you make at Apple, they sell their Apple TV for 169 bucks, and let's say that they make 35 bucks of profit when you buy an Apple TV. I don't know exactly what their profit margin is, although Apple is one of the more profitable companies out there. They make a decent amount of profit because, generally speaking, their products are generally, people like them, and they're willing to pay extra because they work pretty well and they are pretty simple to use. Evidence, a lot of old people like Apple stuff because it's just touch it and it's pretty simple to like figure out, you know, as opposed to PCs, for instance. Like I have had a million questions from people, like in my neighborhood, how do I work my computer, the older people especially, and They never ask me, how do I work my iPad? Never. They just like touch it and it opens, and then they, it's so much simpler. So, okay, iPhones, let's say that you make, this is on the y-axis, by the way, and this is on the x-axis, just a reminder. iPhones, let's say that they sell them for $625 without a contract or something. I bet you anything they're making at least $150 for each phone of profit when they sell you one of those. You see what I mean by iPhones? And I'm making these numbers up, but I know they make a lot more profit on their iPhones versus their Apple TVs. So what's the optimization equation? P equals blah, blah, blah. Everybody try it. I know a couple of people have it, but give them a second to finish. You got it too? Yeah, go ahead. Okay, Mr. M, what is it? If I start that way, how would you finish it? Yep. That's the optimization equation. Then if we ended up with a graph that looked kind of like this, and it was shaded in inside of here, and only that, and that were, or no, those four were possible, which one would you just rule out right away as most profitable? 0, 0, no brainer, can't be that. In general, do you get selling more Y is better? So which of these do you think, A, B, or C? What's your guess on the most profitable? Either A or B, I would agree, because it's got lots of Y. And then I'd check between the two and see which one. Got an answer? No question? Good. How do you set up what? The constraints. Okay, so these equations either are given to you or you have to write them. So let's say I had to write one. If I was going to write the equation for this line right here, this black line, I'd have to know where it touches right there. And that's usually found in its y-intercept. So if they might say something like, well, here is a typical equation. Y equals negative 3x plus 150 or something like that. That's the y-intercept, that's the slope. And sometimes they'll tell you the complicated ones to write are things like this. They sell at least twice as many iPhones as Apple TVs. Okay, so to write one of those, let's say we had back here, Apple TVs were the X, and Y was phones. Then, how would you write the equation for they sell at least, let's start with an easier one. They sell twice as many iPhones as Apple TVs. I probably sell 5 times as many, but let's just make it simple. Write the equation for they sell twice as many iPhones as Apple TVs. This would be if they were just equal. Would you agree with that? Okay, but it's not that. There's twice as many of the one and the other. So tell me, which one is the smaller number? X is the smaller number. So to make these equal to each other, I got to take the smaller number and times it by 2. There you go. Then it can be a little complicated if they change it to at least twice as many. Because then you're not sure if it's this way or if it's that way. Okay, so if they said at least twice as many, what I would do is take some numbers that would be true. Like if they sell at least twice as many iPhones, do you get that would be like 21 compared to 10? That's at least twice as many. Okay, so then you just make a couple numbers and then you stick them in your equation and you see which side is bigger. See what I mean? If X is 10 and Y is 21, which way should the sign go? Which side should the alligator be chomping on? The one on the right's bigger, and therefore it should be like that. That would be really hard. Not likely to throw something that hard on the final, but it's a good question because a lot of kids couldn't do it. Okay, that's another topic. I think our time has come to an end. You are as well prepared as I can help you to be in class. Your job now is to find some things to do for the last minute before you actually take your final. Some thoughts. I did record different questions. They asked me different things in my last hour, so you can go watch the video for that if you want to and see other things being covered. You could also go back and look at, we have this awesome review section for you all built that it's got like little Schoology quizzes in there. So let's say that you know you're really weak on probability. Go try to take the Schoology quiz. It'll check it. I won't count it against you or anything. It'll grade it up and you'll be like, ooh, I only got 5 of those right. Look at the ones you got wrong. Look at the key. Anyway, there's lots of things you can do if you want to study for this test. Okay, that's all I got for you for today.